Hello, Professor. My name is Mohammed Askari. My CW ID is 50379326. And now I'll start sharing my screen. All right. The title of my project today is the Zephyr line, which is a Linux foundation. And I'll start with the introduction of my topic. Introduction is the Zephyr Linux Foundation is an open source real-time operating system designed for embedded and Internet of Things application with limited resources. Zephyr scalable, modular, and security focus. Design offers a powerful yet portable platform for real-time computing. It is highly portable across microcontrollers and embedded system, which supports a wide range of hardware architectures. The microkernel-based architecture provides core features such as multitasking, inter-process communication, device management, networking security, and power management. This project also examines Zephyr's cloud connectivity, security features like secure boot and cryptographic libraries, and its support for multiple communication protocols. This study highlights Zephyr's real-time capabilities, efficiency, and adaptability to real-world deployments and performs evaluations. Results demonstrate Zephyr's advantages and over conventional RTOS solution, making it a strong choice for secure embedded computing, industrial automation, and next generation connecting the devices. Now we'll go on with the features of Zephyr Linux Foundation. The first one would be task management, that is preemptive and cooperative multitasking. IPC, that is communication via messages, queues, first in, first out, and shared memory. Memory management is dynamic, static allocation, and memory pools. Device management, drivers for ART, SPI, 12C, and GPIO, I2C, and GPIO. Networking would be IPv4, IPv6, TCP, IP, Bluetooth, and Wi-Fi support, file system, FAT, and little FS integration. Security would be TLS, SSL, encryption, and secure boot. Power management, there's low power modes and optimized scheduling. Real-time performance, fast response with low latency interrupts. Now we'll go on with the history of Zephyr Linux Foundation. The Zephyr project was launched by the Linux Foundation in 2016, which was aimed to deliver a secure, scalable, and highly portable RTOS for IoT and embedded devices. In the year 2016, the Zephyr was launched by Linux Foundation based on WindRiver's Rocket RTOS. In the period of 2016 and 17, early contributions from companies such as Intel, NXP, Nordic, Linaro support for ARM Cortex-M, Intel x86, and ARC. In the year 2018, we saw added BLE stack, FAT, little FS file system, secure boot, and memory protection. And in the year 2019, we saw RISC-V architecture support introduced. And further, when we move on in 2020, integrated device tree, key configuration, enhanced power management, and ESP32 support. While in the year 2022, 2021, security upgrades such as stack canaries, TLS SSL with embedded TLS, trusted firmware integration. In the year 2022, we saw over 300 boards supported, expanded through developer summits and SIGs. In the year 2023, growth in automotive, industrial, and medical use enhanced cloud integration such as Azure, AWS, and GCP. And from 2024 till now, focus is highly focused on functional safety certifications, artificial intelligence and machine learning as support, TEEs, and IoT security frameworks. Now we'll head on to the architecture of the Linux Foundation. And this is the architecture link of the Linux Foundation, which I have shown right over here. And the next would be architecture. Again, I'd be explaining each layer of the Zephyr Linux Foundation. And it is divided into 7 layers, that is organized into 7 layers. The first one would be application layer. User application code runs as using Zephyr application programming index, example, sensor data processing, actuator control, MQTT/EOP communication. Zephyr APIs, it includes provides access to kernel services, drivers, networking, and system services. OS services and middleware that includes modular services such as networking stack, file systems, security libraries, power management, and USB stack and logging. We're now moving to implementation of the Zephyr Landing Foundation, includes microkernel core that manages threads, context switching, interrupts, synchronization, and timers. Configuration and building the system. K configuration that includes feature selection, CMake that includes build control, Ninja that fast builds, West tool that is project orchestration. Device driver model, it unified a unified driver lifecycle, device tree integration, standardized APIs for peripherals. Peripherals. The next one would be memory and task management. It include dynamic memory allocation such as heaps, laps, pools, isolated thread stacks, memory domains, and user space isolation. Then we will move on to some other implementation of the Zephyr Linux Foundation, that will be networking stack, security integration, power management, that is Tickles kernel, runtime power transition, deep sleep support with SOC and PMUs. Testing and debugging tools include Z-test framework, real-time logging, Shell, GDB, OpenOCD, Sega RTT support. Hardware and board support include 450 plus supported boards that include ARM Cortex-M, RxV, x86, ARC, and Extensa. Now we'll move on to the components. Components of Zephyr Linux Foundation is the components are kernel that manages the task scheduling, multi-threading, interrupts handling, synchronization, and timing for real-time performance. Networking stack that includes the supporting IPv4, IPv6, TCP, UDP, COAP, Wi-Fi, Ethernet, and 6LoWPAN for IoT connectivity. Device drivers include standardized APIs for peripherals that includes GPIO, SPI, I2C, initialized as a boot, ensuring easy cross-board porting. These are some of the more components of the Zephyr Linux Foundation, that is connectivity. It includes and enables communication via Bluetooth, LE, Wi-Fi, IEEE 802.15.14, supports mesh and cloud interactions. Security. This is one of the most important component of the Zephyr Linux Foundation, that is built. It is built in secure boot, stack protection, TLS SSL integration, and memory isolation of safe operations. Power management. It includes APIs for device power states, tickless kernel mode, SOC level deep sleep for energy efficiency. Some of the other components that support function of the Zephyr are kernel as controller. It manages thread execution, IPC, Zephyr modes and mutexes, and real-time interrupt handling. Core for CPU time allocation, event handling, and system scheduling. These are all the components of the support the functions of the Zephyr Linux Foundation. The next one will be networking stack and drivers. Drivers bridge hardware to the next stack. They act as a bridge between hardware and the net stack. The kernel prioritizes network threads and data flow between hardware and applications. Connectivity integration that includes it supports Bluetooth, Wi-Fi, IEEE 802.15.4. It works with drivers and net stack under kernel timing and synchronization. Some of the more components that support the function of Zephyr are securely embedded everywhere. That means secure board, TLS, SSL communication, memory protection across all layers. That includes kernel enforces thread isolation and safe operations. Power management across layers. It coordinates with drivers and kernel for tickless scheduling and deep sleep transitions, optimizes idle time, that is free times, and conserves energy for portable devices. Some of the advantages of Zephyr Linux Foundation, to name a few, are the advantages. The first one would be highly modular and configurable. It would be extensive hardware support. It is a built-in security. Another advantage of the Zephyr Linux Foundation is real-time scheduling and deterministic performance and active open source. It is an active open source community and has a lot of industry support these days. Some of the disadvantages, obviously, of the Zephyr Linux Foundation is a steep learning curve, its limited multimedia and advanced GUI support. Documentation can be complete. A resource usage with multiple modules. Still, it is still maturing as compared to traditional RTOS since it's a new RTOS. The companies that are really involved in the Zephyr Linux Foundation, to name a few, would be Intel Corporation. Intel was the founding member of Zephyr Linux Foundation, contribute in hardware, networking, and security. The Nordic Semiconductor. The Nordic Semiconductors uses Zephyr for BLE and IoT products. NXP Semiconductors, they use integrates Zephyr, they integrate Zephyr into LPC, Kinetis, and I.MX processors. Google, the most popular one, it enhances Zephyr's security frameworks and Google Cloud IoT integration. Linaro, another important one, provides ARM platform support, tool chains, and CI infrastructures. And Texas Instrument, here comes our state. Texas Instruments supports simple link MCUs and wireless connectivity. Adafruit, Street Studio, Arduino. These are community partners for development boards. And the last one, but not the least, would be Ant Micro, is focused on RISC-V support and embedded applications. And we discussed the future of Zephyr Linux Foundation. The trend, the future of Zephyr RTOS is promising as it evolves to meet the demands of embedded and IoT applications. It focuses on areas includes achieving functional safety certification like the ISO 26262 and IEC 61508. This ensures security enhancement will strengthen trusted execution environment and PSA certification alignment. Another future trend of the Zephyr Linux Foundation is expanding cloud integration with companies like AWS, Azure, and cloud for seamlessly connectivity. Support for XPI, AI accelerators, and edge machine learning will continue to grow. And Zephyr's modular build system will enable lighter smart firmware for next generation connected devices. Now we'll be concluding the project. All right. Zephyr RTOS has emerged as a powerful and adaptable platform for modern embedded IoT applications. Its modular design, broad hardware compatibility, real-time capabilities, and integrated security features make it a strong choice for developers seeking reliability and flexibility. Zephyr is continuously evolving to meet industry demands, including safety certifications and seamless cloud integration. With its open source foundation, active community, and commitment to innovation, Zephyr is well positioned to shape the future of the connected, although it's a new one, but it's secure and low power and allow low power devices across industries such as healthcare, automotive, and industrial automation. So that would be it for my project, that is Zephyr Linux Foundation. Now I'd be showing the report of my project. This would be the project report that I'd be submitting on the D2L. All right, so that will be it, Professor. Hope you have a good day. Thank you. Bye bye.